Selamat menyaksikan. Marilah beri tepuk tangan yang meriah. Assalamualaikum warahmatullahi wabarakatuh.
Our Excellency Profesor Dr. Haji Muhammad Zainuddin MA as Director of Universitas Islam Negeri Maulana Malik Ibrahim Malang. Our Excellency Dr. Sri Harini MSI as the Dean of Faculty of Science and Technology and every Vice Dean present.
Head an undergraduate and master program Science in Technology faculty.
the Honorable Dr. Eli Susanti, MSc, as the Chairman of 12th International Conference on Green Technology.
وأهري تنازينا لمساتك جورها فلنأخذ بدعا ثواني لنقدم الاحترام لإخواننا وأخوتنا الذي سقطوا في هذه المساء.
First of all, let us pray and praise to Allah subhanahu wa ta'ala. Because of His blessings and mercy, we can attend this place in a healthy condition.
ثانيا لنسلم ونسلم على نبينا محمد صلى الله عليه وسلم الذين أوصلنا من الظلمات إلى النور.
Ladies and gentlemen, allow us to introduce ourselves. I am Ahmad Zaidan and my partner Penny Rimadana. We will be the master of ceremony for this event.
And welcome to the 12th International Conference of Green Technology. قبل أن نواصل اسمح لي أن نقرأ جدول أعمال هذا الحديث.
The first agenda is Tilawatil Quran, continued by the second agenda, singing Indonesia's national anthem, Indonesia Raya.
وبعد ذلك كلمات رئيس المؤتمر دولة الصانع الأسر للتكنولوجيا حضرائي وكلمات رئيس الجامعة مولانا مالك إبراهيم الإسلامية الحكومية مالang.
Continued by the fifth agenda is prayers, and on to the next agenda. The last agenda is a photo session with all participants.
أيها الحفل البهيج تعالوا نفتتح هذا البرنامج بقراءة بسملة. بسم الله الرحمن الرحيم. بعد ذلك لحصول على بركات هذا الحديث دعنا نسمع كلمات القرآن الجاملة التي ستتلوها زاكية فليتفضل مشكورا.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. وَلِكُلِّ وِجْهَةٌ هُوَ مُوَلِّيهَا فَاسْتَبِقُوا الْخَيْرَاتِ أينما تكونوا يأتي بكم الله جميعا. Bismillahirrahmanirrahim. Ya ayyuhalladzina amanu idza qila lakum إذا قيل لكم تفسحوا في المجالس فافسحوا يفسح الله لكم وإذا قيل انشزوا فانشزوا يرفع الله الذين آمنوا منكم والذين أوتوا العلم درجات والله بما تعملون خبير صدق الله العظيم ثم السلام عليكم ورحمة الله وبركاته.
Sadaqallahul Azim.
On to the next agenda, which is singing Indonesia's national anthem, Indonesia Raya. All attendants are welcome to stand up. All participants are welcome to sit back down.
ذلك كلمة الرئيس الجامعة مولانا ملك إبراهيم الإسلامية الحكومية مالان Profesor Dr. Muhammad Haji Zainuddin MA فليتفضل مشكورا.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. First of all, I would like to thank to Professor Wiesen, Radboud University of Netherlands, Prof. Taufik from California University, Prof. Hadi Susanto, United Arab Emirates, Dr. Engineer Wahyudi Asbi from BRIN, Professor Indah Emilia from University of Buinda, and yes, University of Gajah Mada, Indo MS, and all participants, ladies and gentlemen, allow me in this opportunity to welcome all of the participants of this conference. First of all, may I thank each of our speakers for taking part in this event. The quality and caliber of speakers this year is outstanding. I also want to thank all of you for connecting this morning, and I hope you are looking forward to the discussion as much as I am. The 20th International Conference on Green Technology with topic on empowering innovative science and technology for future environmental perspective, science and technology, faculty of Universitas Islam Negeri UIN Maulana Malik Ibrahim or State Islamic University of Maulana Malik Ibrahim Malang is very pleased to host this conference in Malang. Welcome to Malang City. Ladies and gentlemen, the International Conference on Green Technology is an annual multidisciplinary forum for promoting and fostering interaction between researchers, scientists, academic, and related industry communities in studying the development of science and green technology. This conference introduces newcomers to the field, keep practitioners aware of current development, and provide unparalleled networking opportunities. Innovative science and technology must be developed to offer solutions for new normal adaptation in both pandemic life in all field. Ladies and gentlemen, especially the speakers of this conference, in accordance with the vision and mission of UIN Maulana Malik Ibrahim Malang or State Islamic University Maulana Malik Ibrahim Malang, that is to become a world-class university. This international conference is one among many efforts to make this vision and mission come true. It is part of our concern on contribution of science and technology for enhancing nation productivity and competitiveness in Indonesia. Hopefully, we all can significantly give more contribution to the nation achievement in the not too distant future. Ladies and gentlemen, let me once again thank our fantastic speakers for giving their time and insight today. And I hope all of you watching enjoy the conference. Finally, let's open this conference officially by recite Basmalah. Bismillahirrahmanirrahim. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
The next agenda is prayer that will be delivered by Mr. Johari MSI. Mr. Johari MSI, you are welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let us bow our head for a moment. Pray to God Allah subhanahu wa ta'ala so that our international conference can be precious to all of you. I will let this pray based on the teaching of Islam, and those who are not Muslims, you are pleased to pray according to each of your belief. Let's to say istighfar three times. Astaghfirullahaladzim, astaghfirullahaladzim, astaghfirullahaladzim. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Hamdan syakirin, hamdan na'imin, hamdan yuwafi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa 'azimi sultanik. Allahumma salli wa sallim wa barik ala sayyidina Muhammadin nurid dzati was sirri sari fi sairil asma was sifati wa ala alihi wa sahbihi wa sallim. Allahumma inna nas'aluka salamatan fid din wa afiyatan fil jasad wa ziyadatan fil ilmi wa barakatan fil rizqi wa taubatan qoblal maut wa rahmatan indal maut wa maghfiratan ba'dal maut. Allahumma hawwin alaina fi sakaratil maut wan najata minan nar wal afwa indal hisab. Allahumma arinal haqqa haqqa warzuqna ittiba'ah wa arinal batila batilan warzuqna ijtinabah. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar wa adkhilnal jannata ma'al abrar ya aziz ya ghaffar ya rabbal alamin. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Assalamualaikum warahmatullahi wabarakatuh.
The next agenda is a speech and report that will be delivered by the chairman of 12th International Conference on Green Technology, Dr. Ali Susanti, MSc. Time is yours.
Honorable Director of Universitas Islam Negeri Maulana Malik Ibrahim Malang, respectable the Vice Rector of for Academic Universitas Islam Negeri Maulana Malik Ibrahim Malang, respectable the Vice Rector for Student and Institutional Development Universitas Islam Negeri Maulana Malik Ibrahim Malang, the Dean of Science and Technology Faculty and all Vice Dean, the Head of Undergraduate and Master Program of Science and Technology Faculty, keynote and invited speaker, and all participants. Ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. First of all, let us praise to Allah Subhanahu wa Ta'ala, who has given us all healthy blessings so that we can attend this international conference on green and technology under the theme empowering innovative science and technology for future environmental perspective. Salawat and salam be upon the Prophet Muhammad Sallallahu Alaihi Wasallam, who has got us from the darkness into the brightness. In the industrial era 4.0, the Indonesian nation continues to struggle to advance education in Indonesia through research breakthroughs in the field of science and technology. Therefore, as researchers and academics, we are all expected to be able to help realizing these research in accordance with the fields of science that we are involved in. This scientific meeting is the 12th scientific meeting and scientific meeting held annually by the Faculty of Science and Technology of the Universitas Islam Maulana Malik Ibrahim Malang, with the aim of disseminating research results and as means of exchanging information among researchers. The 12th Icgt is attended by 134 academic participants from various public and private universities, researchers, and students. This activity will be carried out in a hybrid manner for 2 days with 9 prominent speakers who will present their papers at the plenary sessions. Meanwhile, the parallel sessions are divided into 6 offline rooms and 10 online rooms. Paper presented at this conference will be published in the Web of Science Indexes proceeding by the publisher Atlantis Press. On behalf of the organizing committee, we would like to thank all participants who have joined us. Also to all committees who have worked hard so that this conference can run well and smoothly. Finally, I congratulate you on joining the science meeting. Hopefully it will be useful for the development of education in the world. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
أيها الحاضرون وصلنا إلى ناهية هذا الحفل فاحتتما لهذا البرنامج تعالوا نقرأ الحمد لله ودعاء كفارة المجلس الحمد لله رب العالمين سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك.
The next agenda will be a photo session with all participants. All participants are welcome to join the session. We also want to introduce our keynote speakers and invited guests in this event. The first is a rector of Universitas Islam Negeri Maulana Malik Ibrahim Malang, Profesor Dr. Haji M. Zainuddin MA. The second is Vice Rector 1, Profesor Umi Sumbula. The third, Vice Rector 4th, Dr. Isrokun Naja.
And then, Cabin of Faculty Science in Technology is Dr. Bartana, and Decan of Faculty Science in Technology is Dr. Sri Hartin.
And to our keynote speakers is Professor Hadi Susanto from Khalifa University, United Arab Emirates.
And then, Professor Taufik from California Polytechnic State University, USA.
The next speaker is Dr. Ing Wahyudi Hasbi from Satellite Research Technology Center, National Research and Innovation Agency or BRIN, Indonesia.
The next speaker is Professor Chi P. T. S. Wilson from Radbourne University.
And the next speaker Professor Indah Emilia Wijayanti from Universitas Gadjah Mada, Indonesia.
The next speaker is Dr. Novadon Kitana from Kodalakorn University, Thailand.
The next speaker is Dr. Siti Maisuri Patahudin from University of Canberra, Australia.
And the next speaker is Dr. Sri Harini from University Islamic State, Maulana Malik Ibrahim Malang.
And the last but not least speaker is Dr. Erna Hasuti from Universitas Islam Negeri Maulana Malik Ibrahim Malang. All participants are welcome to have a 10-minute break from this point.
ada Nimas Ega dan Nimas Andini.
Lah menunggu hasil trading cair, makanya trading forex di
The next agenda is a lecturing session by the lecturer Professor Wahyudi Hasbi and Professor Indah Emilia Wijayanti that will be moderated by Mrs. Ari Kusumastuti, MSI. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. First of all, I would like to express my deep gratitude to Allah Subhanahu wa Ta'ala, who has given us some mercy and blessing so we can attend in this conference without any problems. And secondly, salawat and salam delivered to our Prophet Muhammad Sallallahu Alaihi Wasallam, who bring us from the darkness to the lightness. So we have the guidance in our daily activity. Welcome and respect to our speakers. Mr. Wahyudi Hasbi, PhD, and Professor Indah Emilia Wijayanti, and my respect to all of the participants in the International Conference on Green Technology 2022, and my honorable to the official ranks and also the chairman and committees of the International Conference on Green Technology 2022. In this occasion, I'm Ari Kusumastuti. I'm gonna conduct the plenary sessions to accompany the speakers in having this speaking for this morning from 9:45 to 11 a.m. With the first speaker is gonna conduct by Mr. Wahyudi Hasbi, PhD. First of all, I have to read first the CV of the speakers. Mr. Hasbi Wahyudi, PhD, was born in Biak, Papua. Education, bachelor in the jurusan Fisika, Universitas Hasanuddin Makassar, Indonesia, 2000, and the master degree in Ilmu Komputer in Institut Pertanian Bogor, 2011, and the candidate doctor in the field of the system satellite from the Technische Universität Berlin, German. And the profession, he is a researcher in the field of disseminations in the Pusat Teknologi Satelit, a lembaga penerbangan and antariksa nasional 8 since 2011, Chief Engineer Satelit 8A3 IPB, have been orbited since 2016. System Engineer Pengembangan Satelit 8A2, 8 Orari, since 2010 and 2013, and have been orbited in 2015. And the member of the engineer team for the development of Satelit 8 Tubasat, and which is firstly developed by the Technische Universität Berlin 2004 and launched in 2007. Appreciations. He is award recipient in Satya Lancana Wira Karya from the President Republik Indonesia, particularly for the awards of his services in the development satellite dedicated to the nation and country Indonesia. So it is why Mr. Hasbi as the role model of the others from the government. And Satya Lancana 10 tahun from the President RI, and also award recipient in Kepala 8 as an outstanding employee. Member and professional organizations, yes, as the chairman of IEEE sections 2021, member in senior IEEE, Aerospace and Electronic System, chair division professional activity IEEE Indonesia sections 2019 to 2020, vice chairman of the IEEE Indonesia sections since 2017-2019, a vice chairman of the Indonesian sections joint chapter of IEEE Aerospace and Electronic System and IEEE Geoscience and Remote Sensing Society since 2013. General Chair IEEE International Conference on Aerospace and Remote Sensing 2014 and 2015 and 2018 and 2019. And also the member of Organisasi Radio Amatir Indonesia Orari, which call sign YD1PRY, since 2010 and push the development of radio amatir in 8E2 Orari for the communication backup satellite, especially if in Indonesia happened the disaster. And also a member of Peneliti Indonesia Himapindo. Research field, he is conducting the research in the system satellite, microsatellite, komunikasi satellite, and muatan satellite. And also active in the workshop held by several universities around the world, and published more than 45 papers in the reputational journals, and also 2 international books. And my first speaker gonna conduct the small satellite rules in disaster mitigations and environment monitoring in Indonesia today. And my second speaker, sorry. He is Professor Dr. Indah Emilia Wijayanti MSI, institutions, Department Mathematics, FMIPA UGM, Skip Utara Yogyakarta, 55281. Homepage, we can take a look in the CV versions PDF. And the education's bachelor degree in UGM, mathematics, 1988 to 1993, in the specific research in the theory system in mathematics. Master degree in UGM Universitas Gadjah Mada also, which is in the field mathematics, 1996 to 1998, with the concern in the bentuk Jordan dan terapannya. And the doctoral degree he conducted in the Heinrich Heine University of Düsseldorf, Germany, mathematics 2002 until 2006, and conduct the field of research that is coprime and comodules. Allow me to separate these sessions into 3 parts. Part 1, we can start the speaking from Professor Hasbi Wahyudi, PhD, start from 9:45 to 10:15, and continue with Professor Indah Emilia, start from 10:15 to 10:45. And the last sessions is the discussions among the participants and also the speakers, about 10 minutes from 10:45 until 11. All right, let's listen to the first presentations and also directly continue to the second presenter. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Bu Aris. Very good morning to all of you. So thank you very much. Actually, I would like to express my thanks to the committee and also, of course, for the of this conference that inviting me to speak about small satellite roles in disaster and environment monitoring. So okay, I think it's better because this is a discussion, so I think I would like not to use this podium but rather speak directly, right? Down. I think it's better. So okay, so I think now you can see that the as already the moderator introduced me. I came from BRIN, or National Research and Innovation Agency, and then also currently I'm the head of this research center, and also in IEEE I'm the chair of the IEEE Indonesia section. So next, please. Okay, just to let you know that. Of course, why space application is very urgent for Indonesia. There are several reasons. As you can see that we are quite extensive and diverse maritime continent geography, and also, as you remember, in 1976, Indonesia is the 3rd country in the world using satellite communications, because we have a lot of islands. We have like 17,000 islands that we need to be connected, so that's the reason why we need a satellite system. And then also, of course, a satellite system is very important to have the Earth observation. That's what we are talking about right now. And also, of course, navigation. Without navigation, you cannot sending food your home with Gojek, Grab, or whatever is it, right? So you need satellite navigation. Otherwise, you cannot do those things. And then also, of course, for defense and security. Everybody, now you know that there is a war in the other part of the world, and everybody using their asset, including space asset for defense and security. And also during a disaster, this is one of the topic that we will also explore a bit. And of course, health and education. During the COVID last 2 years, within these 2 years, we know that everybody has to be connected with the Zoom or MS Team, WebEx or whatever. And then of course we need satellite system, right? And then, yes, and then you can see here that LAPAN is already started in 1963. And then we move further and further, and now we are integrating under BRIN. Next slide, please. Okay, this is the new organization of BRIN. So you can see here. So under President Decree number 78 2021, all the research center under government institute is jointly merged under BRIN. So you can see here all LAPAN, LIPI, BPPT, LIPI, BATAN, everything is merged, including all research institute from the ministry, including Ministry of Religion. So there is no more research for research center for religion, for example, in Ministry of Religion, because everything now under BRIN. And research of religions come under the social and humaniora research organization research. Okay, next. Okay, now we will see here that Indonesia actually has already a national satellite roadmap under Presidential Decree number 45 in 2017, and we have the roadmap until 2040. So we are starting with developing the small satellite, and later on we will go for a big satellite system, including facility and stuff like that here. And then later on we will also try to develop our own navigational satellite, because it's very important for the big country like us. Next please. Okay, and then we can see here, this is at least 3 national need of why the satellite is very important. As I already mentioned, the satellite used for Earth observation or remote sensing, specifically for civil and defense, and also of course for the telecommunication, as we know, and navigation, right? Next. Next please. Okay, so now why remote sensing is very important for Indonesia as well. So you can see here that as I mentioned in the beginning, that we are vast archipelagos countries, and we require the remote sensing technology for monitoring. And also why the remote sensing satellite is important, because we can get the very wide coverage and consistent gain, and also near real time, relatively low cost, factual, and also we can measure the changes in our environment. Next please. So this is if we connect, what is the connection between space technology and SDGs? As we know, our United Nations create what they call as Sustainable Development Goals, and this green color is the connection between SDGs and space technology. Next. So this is some of the example. For example, SDGs number 1, no poverty. So we can see here how satellite can detect the crop of paddy, for example, and also this data can be used for crop insurance. In any case the crop is failed, the farmer can request insurance to pay all the bills actually. Next. And then this is number 2, like zero hunger. So we should not be hungry anymore. And then of course this also can be connected with the satellite, because with the satellite we can, for example, see where is the place that we can harvest our paddy field very soon, or where is the place that we cannot get the paddy very soon. And from that point we can calculate how many hectares will be harvesting, and what is the capacity and paddy production, and so on. This can be done all by satellite system. Next. This is also another example. This is in Karawang, yeah. In Karawang, you can see how can we distinguish where is the paddy field that ready to be harvested or not. Next again. And then this is for another usage of the data from the satellite. For example, how we can detect disaster happen, especially for forest fire. In Kalimantan or Sumatra, every year we got the problem of forest fire, and this can be detected easily by the satellite system. Next. Yeah, and then this is number 6. Clean water and sanitation also can be detected by satellite system. So remote sensing can be used as well to detect where we can get clean water as well. Next, please. And then also for development of city, we can see here how can we monitor Jakarta, for example, changes from 2007 to 2013. Yeah. And we can see how big the open space, and even from the satellite data we know that Jakarta will sinking very soon. Now it's 30 centimeters down, and later on maybe will become more and more. That's the reason why government changed the new city now to Kalimantan, because they want to avoid this one. Next, please. And then this is also another usage. So for spatial planning of the city, of course, we can use satellite system so that we can make all the city management, for example, by using the remote sensing data. Next, please. Climate action, also the same question. So how can we use the satellite for climate action as well? So from here we can see how we can detect how changes is Kalimantan is right now, right? So this is very important. Next. Now we come to the earthquake and volcano. If you have your apps application from BMKG, you will always get a message that there is something shaking around us, and it's become more and more. And the reason is because of this. You can see here why we are always shaking, because the ring of fires is just near us, and everybody has to know that. Next, please. So this is the actually 3 satellites that we have developed. This is 8A2 flying from west to east, and then from north to south. So this is 8A2, this is 8A3. So and then one more satellite, we call it 8A1 or 8Tubsat, already 15 years in orbit. So this satellite has height about altitude about 650 kilometers, and the other one is 550 kilometers. So we launch it in India, and it gives us all the data. Next, please. Next. Okay, so this is our first satellite. You can see myself very young here. So when we developed the first satellite, so this is the satellite, very small, just like a box. But you can see we can put the video camera on board the satellite, and then you can see this image just like you are an astronaut. So put the video camera like this camera on board, and then from this point we can monitor what is going on in our Earth. And this is videos over Italy, so we can take any picture, any videos in other countries from above. Next one. And then this will be very interesting. Who knows this one? Where is this? This also video camera, and if somebody wants to guess, where is this? A bit wrong. Still wrong. Yeah, of course, Merapi. So you can see here from the satellite we can easily see how Merapi is going on, and then by using a video camera you can put the video camera become a frame picture, and then from picture you can try to make land cover and land use analysis, and it's very easy. Next. Okay, and then our second satellite that we developed, we call it 8A2. So you can see here, we use the satellite for many activities, including ship monitoring. So we monitor all the ship around the world and around Indonesia, and also use the satellite when a disaster happens. Next. And then this is, we call it 8A3 satellite. As I mentioned before, the orbital position is north to south, so it's always flying north to south. And then from this point, we can detect so many data, for example, AIS as well. So this is ships data all around the world. This is magnetometer or Earth magnetic field. And then this is, of course, Indonesia. So we can measure Indonesia and monitor that one as well. Next, please. Now, who knows where is this? Somebody knows where is this countries is? This is Osaka. So this is there is a story behind this image actually. So there is a student from Osaka schools, and then they request us, Pak Yudi, can you take a picture of our school from your own satellite? And then I say yes, of course. And then this is the image. So this is Osaka, and we can see here this. The red means all is green. This is forest or planting and so on. And you can see here in the city, almost there is, in Japan especially, there is no plant. In the city especially, right? Only small red color here, because this false color, red, green, blue, near infrared combined. That's the reason why the color is like this. Next. And then this is response to forest fire in Vietnam. So in Vietnam, they got a very big forest fire, and they request us whether we can capture some data for them, so that they identify how big is the forest fire is. And this is some of the data, including a heavy flooding in Japan. Our partner in Hokkaido University also asking us whether we can take a picture during the heavy flooding there, and we send the image. Next. And then one quite important thing is we also measure the Earth magnetic field. If you remember, a few months ago, there is news in the public paper saying that the Earth magnetic field is changing, and people say that Kiamat will come. Right? Kiamat will come because the Earth magnetic field will change now. But we'll see next whether it's true or not. We'll see. So this is the magnetometer data processing flow from the raw data up to we get all the details. Next. So this is the result. So the Earth still there, luckily. So Alhamdulillah, Kiamat will not come soon, I hope. Because the north and south still there. If it is changing here, then we have a problem. If the red color is here and here, then the Earth will move another in another turn, and then I don't know, something big happens. We have to immediately, I don't know, go to Mars. Okay, so this is the Earth magnetic field measured by our satellite, and we compare with very expensive satellite. So this is SWAM satellite from European countries, and you can see from the data that our data is 94% almost accurate with the model. So the result is quite good with very cheap cost. Next. This is during disaster. Who knows this? Okay, of course. The title is there. Krakatawa is happens. Okay, yeah. So this is when Krakatawa eruption in 2020. So we can see how big is it. So this also collected by our satellite data. Next. This is another several disaster image in August 2018 in Lombok. This is in Palu, of course, and then this again in Bali. Next. So this is another result of remote sensing for the environment and used by Kemenko Marves, KKP, KLHK, and all police, of course, and Bakamla. This is to measure The oil spill, you know, all the ship is actually throw all the oil spill. I know that Professor Franz will talk about plastic today, and this is almost the same problem here. So we'll hear Professor Franz later on. So this is almost the same problems because all the ships, they just throw dirty oil in our oceans, and we eat the fish, right? So we eat the fish with oil. It's crazy. Okay, next. Next, please. Okay. So this is during disaster again. This is liquefaction in Palu. Next. Next. Okay. So this is also when landslide happens. So during a landslide, we can measure before and after, and we can identify how big is the landslide happens because of this. Next. This is a disaster again, tsunami. So before tsunami and after tsunami, we can identify how big the area affected by tsunami as well by using satellite remote sensing data. Next. This is liquefaction, as I mentioned. So this is before and after. You can see how many hectares affected by liquefaction in Palu. Next lagi. So this is the application that everybody can use it. This is a fire hotspot to identify where is the hotspot happens. Next. And then this is okay. This is maybe important for people who working in telecommunications system. So when disaster happens, you can use only handy talkie that you can buy in the market like 300,000 rupiah. So HT, the handy talkie that the person used, also can be used to send a message to our satellite during a disaster. Next. You see these guys only using handy talkie, right? And then he would like to talk over the satellite like this, and then everybody will understand. And we also teach the young people like scout or pramuka, yeah. See, he's very happy using handy talkie, and he can talk 2,000 kilometers far away. Next. This is also if you can click this one, this video, you can hear the sound. There is a one person that has this is in Palu during a disaster, and then he communicate when disaster happens. Next. So because this is very important, so we teach the people, the community of Indonesia, how they can use the satellite communication if disaster happen, and this is really useful for them, and because we have several disaster already. Next. And then this is another type of messaging, so not by voice but now by SMS. So you can send message type, SMS type by using handy talkie again, HT lagi, and then you can send a message, and you can see here they are talking each other. Next. This is during a disaster, like this is disaster happened in Philippines, and somebody from Philippines send a message, digital message through the satellite system, announce that typhoon is coming. So this is also can be used. Next. So for the small satellite development, we can do all the design component and assembly integration and launch operation and mission operation all in Indonesia already. So if you like to visit us, please come to Bogor, come to my center, and I will show you how we develop the satellite system. Next. So this is our next satellite. We call it Nusantara Earth Observation Constellation Satellite. Will be launched next year. And then this also will carry a medium resolution camera to detect all the environment monitoring, including the high resolution image like 5 to 10 meters to monitor all the ships, especially for maritime surveillance. And this is also another AI system. And you can see here. Oh yeah, and then one more, we have a new camera system coming from Hokkaido University. So they put thermal sensor, and they put it in our satellite system. Next. So this is the facility, because now we are under BRIN, so actually all the facility here is open for everybody. So especially from University Islam Malang also can use the facility if you really wants to use the lab that we have. So this is the collimator lab. Collimator is the tools to measure the alignment of CCD or CMOS camera sensor. And then we have a clean room 100,000 class. We have also integrating spare. Integrating spare is actually a light that we can use to measure the pitch netting of your of the lenses. So just one tip, if you like to take a picture with your handphone, please stand in the middle, not in the side. Do you know why? Just try to look the result. You will become fat. Why is that? Why you suddenly become fat when you are in the side? Because of this pitch netting effect of the lenses. So that's the reason why if you use your handy, just try to be in the center, then you will be fine. Okay. And then but anyway, this fat effect can be corrected if you use these tools to remodel the real picture. Yeah. But if you don't have this one, then you cannot do this. And we use this satellite to this system to calibrate our image. That's the reason why you can see our image is very aligned. Okay. And then we have a vibration test. This is especially to test all the components before flight. And then also we have thermal vacuum chamber here, and we control the satellite directly from our ground station in Bogor. So we have also thermal vacuum chamber here, and then we have an anechoic chamber for RF and EMC system. If you like to test EMC, especially because somebody from telecommunication subject, you can also use our facility here. Okay, next. So this is another ground station. So we have to monitor our satellite. We have several ground stations in Indonesia, and also we have one station in the North Pole. So I'm sure that the Earth is still there. We have one station in the North Pole. So we really developed this one. So it's located here in Svalbard. It's very north, and to monitor our satellite system. Next. Okay, this is another satellite system that currently we are also designing. So this will consist of 10 satellite system. So to support disaster early warning system, maritime surveillance, machine to machine, and IoT, of course. Somebody like to start the IoT system, you can also join us to have this research as well from the satellite system. Next. So this is one I think several more slides. So this is the additional initiative from BRIN. So BRIN, under BRIN now we have initiative to deploy like 19 satellites for Indonesia. Consists of very high resolution satellite, synthetic aperture radar, and high resolution satellite, and also IoT system satellite to detect all the ships, all the plane, and many others here. Next. This is the simulation. So you can see the simulation. This is Indonesia, and we have 6 satellites all around, and this is another equatorial satellite system here. So with this system we can monitor Indonesia rapidly, including real time, and also one more geo satellite here will come. See, this is a communication satellite will come over. Okay, so next, I think that's all for me. So thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
And we go to the second presentations. I want to share you about the activity of the second speaker. She has conducted so many articles in her field. We can take a look in the PDF. Maybe the committee can share it to the participants. And the organizations, she is Kepala Laboratorium Aljabar Departemen Matematika FMIPA UGM since 2022 until 2025. President Indonesia Mathematical Society Indo MS 2020-2022, and next 2022 until 2024. And editorial-in-chief, Journal of Indonesian Mathematics Society, GIMS, 2019 to 2024, Executive Editor, Journal of Indonesian Mathematical Society, GIMS, 2017 until 2018. Penggiat Aljabar join seminar komunitas peminat Aljabar di DIY dan Jawa Tengah, 2017 to 2020. Wakil Koordinator Komunitas Peminat Aljabar KPA 2015 until 2018, Koordinator Bidang Penelitian dan Pengembangan Matematika Indonesia Mathematical Society Indo MS 2014 until 2015, Koordinator Penelitian Bidang Aljabar Indonesia Mathematical Society Indo MS 2012 until 2013. Sekretaris Indonesia Mathematical Society Indo MS 2008 until 2010, and the last Koordinator Himpunan Peminat Aljabar Komunitas Peminat Aljabar Indonesia Algebraic Society 2007 until 2011. And the experience in publications of the books since 2010 until 2022. She conducts so many interesting and important books in the field of the algebra. So the time is yours, Professor Indah Emilia.
Thank you. Thank you very much for introduce me to the audience. Good morning. Assalamualaikum warahmatullahi wabarakatuh. It is my pleasure to be here with all of you, online and offline here. Thank you to the committee who invite me to come to Malang, a beautiful city and delicious food, and also the nice people. I would like to share what is the field of my interesting field, algebra. Algebra is one of the branch of mathematics which is very abstract, you know. Mathematics itself is abstract and algebra is more abstract than very abstract, And I read the theme of this conference. This is about green technology, so I think what can we do? What can we do with algebra or mathematics in this topic? Actually, it is a hard topic. I think about what kind of possibilities to share here, and finally I find that maybe this is our contribution to make a green technology. Maybe a little contribution, but actually we need it, because now we cannot live without technology. For example, yesterday WhatsApp it was broken or something trouble in WhatsApp, and maybe an hour, I don't know, about an hour, and I believe that the people in Indonesia, maybe in this area, has some troubles. For example, I cannot contact Bu Eli yesterday, because WhatsApp is trouble. This is one example of how important technology is for us today. Okay, so I would like to share about what is contribution of algebra in our technology. Next. Next. I try to make not very abstract. So first I deliver some pictures here. This is what happened maybe here in this room. We sit on one table, but everybody in this table see the handphone. Not to the people in beside us. Everyone also the handphone, contact to another people, another place. But we we don't pay attention to the people next to us. Yeah. And also, yeah, everything we need internet in this case, yeah, or to make a payment, to communicate with our students, our colleagues, our parents, yeah, we need this technology. And as Professor Hasbi said that now we need the satellite and so on to communicate each other, and it is also the situation today. Let me move here. Okay, next, yeah. So I want to focus in this part, in which we make everything with internet. For example, for internet banking, online payment, or maybe send email, send WhatsApp or message. We use it every day, almost every hours. Even we can do more than one activities in one moment. So we sit in the table, one table, but we also can make discussion with our students, maybe, or maybe we can also make a payment during our event here. Yeah, we attend conference and also we can make a payment by online. Yeah, this is our activities. Next. Yeah, next. Yeah, behind our activities, actually, there is something important. This we call it data and information security. This is a big issue this year, or maybe, yeah, many issues about security, data security and information security. So when we send email, for example, or we receive email, there is we need a protection to our data, such that the other the other people who is not in is not in our no. I mean, there is somebody else maybe want to know what we send to our colleague, want to catch the data, and we have to protect our data. Yeah, it is in our situation. And what can we do with this situation? Because every day, every minute, we make this activity. Next. So what is the relation, this case with the green technology? Yeah, in data protection, we need computer, and we need also an algorithm. We call it cryptography or crypto system. And this system, we make a computation. Computation in the computer needs energy. Yeah, more if we do with big numbers, for example, the very big numbers with some digits, yeah, we multiply, we sum these numbers. The computer needs more energy. Yeah, so if we can make the algorithm efficiently, we can save the energy. Yeah, this is the point. So this is maybe the contribution of mathematics or algebra to make green technology.
By we sum these numbers, the computer needs more energy. Yeah. So if we can make the algorithm efficiently, we can save the energy. Yeah, this is the point. So this is maybe the contribution of mathematics or algebra to make green technology. By we sum these numbers, the computer needs more energy. Yeah. So if we can make the algorithm efficiently, yeah, this is the point.
Can I continue? Yes. Yeah, well, maybe next. Next. Next, please.
Next, please.
Ya. Gimana? Okay. Yeah. Can we continue the slide? Yeah, this is our goal. Yeah, if it is possible, it is very, very, very good if we can have the green technology in every aspect of our life, including the cryptography or crypto system for the data security. Yeah. Next. I'm sorry, this is a more technical, but the journey or the adventure of mathematicians is in this part. So our adventure is how to do with matrix, with numbers, with something technically, but we try to make algorithm system very efficient with this adventure. Yeah. So I invite you to join our words in adventure and numbers. Yeah, this is the system cryptography system. Maybe the picture is very small. Yeah. We in today I focus in RSI. This is very very important cryptography system, and we use it today. This RSI introduced by these researchers, yeah, Rivers, Samir, and Adelman in this 1977 and published in 1978 in their paper. The system is like this. So we can illustrate the crypto system like two people, Alice and Bob, who want to communicate each other, and they use private key and also public key. And this is the third part, we call it if, yeah, want to know what is Alice and Bob communicate about. Yeah, and we in crypto system focus in how to we make a public key and as safe as possible, such that the other people cannot cannot hack this key, such that the message deliver safely to another. Yeah, this is the system. And next. Yeah, Alice and Bob agreed use certain secret key, and then Alice sent a plain text, a message, which is encrypted by her key to Bob. So first, she has to encrypt the message and then send it to Bob. And Bob received the message, and he tried to understand the message from Alice with the key. Yeah. And the cryptography system focus in key generating, so how to make the key safely, and it's used in encryption and decryption. Yeah, next. Yeah, a little bit, okay. In mathematics, we have this definition. Yeah, what does this cryptography means? From mathematics point of view, it is like 5 tuples. We call it P, C, K, E, and D, where this is the set of plain text, the set of ciphertext, the set of key, and also the function here. Now, such that this is the function who has inverse, yeah, such that if we compose two functions, we can get the plain text once again, yeah. But this is a definition of cryptography from mathematics point of view, yeah. And then next, as I mentioned before, this is one of the crypto system, RSA. This is very simple because we only use the integer modulo n, and also the prime numbers, the different prime numbers. And we also need tools. We need division algorithm and also sinus remainder theorem. Students in undergraduate understand what is what is this, yeah? They familiar with this, yeah? So this is very simple algorithm. But until now, we still use this RSI. This is relatively safe until today, but not absolutely safe, no. But until now, we still use it, yeah. So the safety in cryptography is relation to some conditions, yeah. And the other, for example, El-Gamal. This is another system, and also another tools we use here. Yeah. Okay. Next. Next, yeah. It is it's very simple, yeah. If we want to use RSA, we need choose two prime numbers P and Q. If it is possible, we choose large as possible numbers, not 3 or 5, no, but some digits, maybe 10 digits or maybe 15 digits prime numbers, yeah. And then we can multiply them, n is p times q, and also we have this function, and we choose a random number e between 1 and v of n, and with the condition that the GCD of v of n and e is equal 1, so they are relatively prime, yeah. And then we compute d is e inverse of e modulo this vn, use this algorithm, and as a public key, is the pair of n and e, and private key is p, q, and d. This is the steps of how we can generate key. We call it a public key and also private key. Public key means everyone can see this key, but private key only Alice and Bob know this key. But public key, everybody can see this. Yeah. Remember that this n, we can see n, but we don't know what is p and what is q. For example, we know n is, for example, 6, 5. Yeah. We know some we know some numbers, but we have to, if we want to know this p and q, we should guess what is the factor of n. So this is the problem, the main problem of RSA. How we can factorize the number into multiplication of two prime numbers. Yeah. This is a process encryption and decryption. If Alice send a message, call it M, for example, yeah, then she should encrypt the message into C, and we have ciphertext here. C is equal to M power E power 2E modulo N. And then if Bob want to know what is the message, he has to use this formula. Yeah. Okay, next. Mathematically, the steps above is successful because if we compute C power to D, we can get this message, this plain text again. Yeah. So I give some example. One example here. Please a little bit above. Yeah. Now, for example, I choose prime numbers. P is 47 and Q is 71. Then we can multiply P and Q. We get this one, and we compute V of n is we get this one. Now we choose the random number is 79. 79 is between 1 and 3,220, and this is relatively prime with this V of n. Yeah, we can compute D is like this, and finally we have public key is this one, and private key is this one. Yeah, next. Now we try to send the message, for example, hello Alice. Yeah. First we change this hello Alice to numbers first. Yeah. This is the formula. So A is equal to 00, B is equal to 01, C is equal to 0, 2, and so on. Yeah. And we translate this hello Alice to numbers like this. Yeah, space is ignored. Yeah, we don't. Yes, this space here we ignore this space. Yeah. So hello Alice become this code, and moreover we have to encrypt this message first. We get C with this formula. Yeah, and actually the cheaper text from M like this become C like this. So when Alice send the message, she send this message, yeah, and Bob received this message. Bob want to understand what is the meaning of this code, so he has to make decryption, yeah, with the formula. Next, yeah, the formula to decrypt is like this: C power to D. So this ciphertext power to this numbers modulo these numbers, and when we compute, we get again the plain text. So Bob know that the message is hello Alice. Yeah, this is very simple. But if the number is very big, it needs more energy for the computer to compute it. For example, can I again scroll down, please? Hello? Yeah. Then the slide before, please. Yeah. Before again. Yeah. For example, here, if I choose the prime numbers and not P and Q, but something larger than more large than bigger than P, more bigger than Q. So you can imagine how big the number you do it. Yeah. So this one. Yeah. Okay. Next. This is the only the description how we can analyze the complexity of the system. Yeah. Recently, the fastest algorithm to factor in n has complexity like this. Yeah. So the problem is to factorize the n, and the complexity like this. This is the impact comes to the computer. Yeah. If we have the normal computer, maybe the computer should work hard, very hard. Yeah. If we have supercomputer, yeah, maybe this, but still hard. Yeah. This is a number. So bigger number, harder the computer do. Yeah. Next. Yeah. In the next slide, I give some examples how people try to modify RSI to another system. If RSI, conventional RSI, we use integer modulo n. Here, the researcher try to use matrices. Yeah, so we conduct with a group of matrices, and also the some formula here, and also some formula here. And a computer, when it works with matrices, the operation of matrices, multiplication matrix and addition matrix, the computer will work hard also. Yeah. Okay, next. Yeah, next. I think this is the same algorithm, yeah, to encrypt and decrypt. Okay, next. Yeah, this is also yeah. I think this is something wrong. Yeah. And second, the second line is should not here. Yeah. So the next RSI is use elliptic curve. In this case, we need to choose an elliptic curve, certain elliptic curves with parameters P and Q. P and Q is still prime numbers. So in this RSI, we still use prime numbers to make the elliptic curve. And also we generate some numbers from this one, and then we can continue the algorithm similar with the conventional RSI. And next. encryption and decryption also has the same similar formula. Yeah, the message from this elliptic curve, and compute the ciphertext like this, and then compute plain text again with this formula. Okay, next. This is also the variant of RSA. We have a Gaussian integer. Gaussian integer is the part of complex numbers, which is the A and B, here the integer. And we define this norm of alpha as the number we generate in this system. Yeah. And from algebra point of view, this Gaussian integer has a good property. It is a Euclidean domain, and also in this Euclidean domain we can apply a division algorithm. Yeah, next. Okay, we can see in this key generating and also in encryption and decryption, they have the similar steps. Yeah, only here they have different. Yeah, the function v of n, yeah, a little bit different. And also the number, random number here also different, and but the other steps quite similar. Yeah. Okay, next. Yeah, this is some remarks from Gaussian integer. Actually, there is something modification of this system. So we can do this Gaussian integer modulo ideal generated by a certain prime number here. Yeah, so something like modification from Gaussian integer RSA. Okay, next. Yeah, now we come to the something more abstract than we mentioned before. In mathematics, integer is not very abstract. Yeah, this is still can see. Yeah, and also matrix over integer is also quite concrete. Yeah, but if we abstract the situation into a Dedekind ring, for example, so we come to the abstract notion. Yeah, how we can make abstraction or generalization of RSA to this notion. This is introduced by Petkova in 2016. He generalized RSA over Z to RSA over Dedekind ring. Yeah. So the aim is to construct a new algorithm which is resistant to quantum computer attack. So quantum computer attack is also a big issue in cryptography, and not in RSA but another system also try to make how we can protect our data from computer quantum attack, because by Shor algorithm the factorization of n into p times q will be very easy if computer quantum exists. So we know from the previous slide that RSA depends on this n. If somebody know n was this p and was this q, so he or she can attack the data, attack the system, can steal the data. So the main problem is how to factorize n, and quantum computer can do it easily. So everybody is worried about this. If it is actually happen, so we can lose our data easily. So this is one system how we can resist this quantum computer attack from this one. What is Dedekind ring? This is a ring, has a notarian commutative ring with unity, also integrally closed, and every non-zero prime ideal in R is maximal. This is the example. Yeah, the example. Okay, next. Yeah, okay. Maybe you can skip this. This is a technically condition in this R Dedekind ring. Yeah, for example, for every maximal ideal, the quotient RMM is finite. This is the technically condition for this ring. Yeah. Okay, next. The algorithm is a little bit more complicated, yeah, like this, because we conduct with the abstract thing, yeah, the ideal, maximal ideal, and we can follow this step. For example, we should choose two maximal ideals in R, which is not the same, and we can multiply these ideals into I, and we can compute phi of I like this. Yeah, this is the cardinality or the order of unity group from R modulo M1, and this is the cardinality of group of unity from R over M2. This is index 2. Yeah. And from this we can choose random numbers such that the GCD, the greatest common divisor from phi of I with E is equal 1. They are relatively prime, and we compute this and also this. Yeah, this is the key. You know that the key is quite a little bit different because we use this ideal as a key, and also the private key we use this set. Yeah, this set. Okay. And then this is the process of encryption and decryption. The message itself is the subset of R, subset of this ring, and we can compute the ciphertext with this formula, and then we can get the plain text again with this formula. Okay, next. This one is also surprising me because the author, the researcher here, Long, can make an abstraction to the all of RSA variants. He used the semi-group here. Yeah. So this is the proposition to preparation the system. We have three semi-groups and also a non-zero subset of them. Yeah. And also a function or mapping from Y to U and also Y to V. This is semi-group homomorphisms. And this is the certain condition, a very, very complicated condition, yeah. And from this situation, we can abstract the RSA into abstract notion, yeah. Next. Next.
1 minute left, Ibu.
Okay, yeah. Yeah, this is the abstract notion of RSA crypto system. Use a semi-group, yeah. First, we choose integer E satisfies this one, and also the relatively prime E and L, yeah. And we choose D such that the multiplication is 1 modulo L, and public key is E and private key is D. This is quite simple, more simpler than the other RSA, yeah. But the condition is not simple. Yeah, we make a preparation first before we get this algorithm. Encryption and decryption also have the same formula, a similar formula, not same but similar. Yeah. Okay, I think it is the last. Next, yeah. Next is the reference. Yeah. We collect some information from this reference, and we still do this. Observation in Universitas Gadjah Mada in UGM, we in the short I hope in the not very long time we will launch the center of cryptography and cybersecurity. Yeah, we prepare to make this center, and now we have an active discussion every 2 weeks with the colleagues from Poltek SSN, Poltek Siber dan Sandi Negara, and also with a colleague from Sandiguna. Sandiguna is from industry, from this security, and also with colleague from NTU Singapore. We have 2 weeks active discussion, and we concerned about cryptography and also cybersecurity, because the very last issue in Indonesia is Undang-Undang Perlindungan Data Pribadi has already launched already, and the people in all people. I mean, we have to concern about this, about data security, now, because there is a undang-undang now, there is a law now, so we have to be careful to use another data. Yeah, so we want to contribute in this part to make maybe education to the people how to make a system, security system to the office, maybe to the bank, to the another institution. So I think this is my talk today. Thank you very much for attention.
Thank you very much for both speakers. So many interesting that both their field contribute in developing of the technology in the future. Now your turn for participants to have the discussions with the speakers. I bound 3 participants to have the questions. Say your name and also the institutions. Thank you.
Okay, thank you very much. I'm really happy to be here to hear insights and new knowledge because I'm not from technology or science background. My background is from religion and ecology. I have a question for Professor Wahyudi. Oh, okay, my name is Zaimatu Saadia from PhD researcher at Redboard University, Nijmegen. I have question for Bapak Wahyudi. We are in environmentalism, we have 2 jargon regarding disasters. Natural disaster and human-made disasters. You have already explained about how the satellite help us to know the situation of our country, the Earth, and it helps to know the data, the situation, and etc. My question is about how LAPAN or the satellite also help to know the situation of pollution that made by us, by human, by a factory, by industry, then it become a key of governmental policy to give permit to the industry to continue their work. For instance, we have a textile industry. We also have we also mine cars, mountains. Of course, there are adverse impact to the environment. So, do LAPAN also concerned about this one? Yeah, then can help the government to decide what is the best solution for this situation. Thank you.
Thank you very much. And one more participants again. You can raise your hand. Okay. Okay. One more participant maybe can share the questions to Prof. Indah Emilia. Maybe while waiting for the next audience, you can.
Okay, so thank you Thank you very much. These two questions is always fascinating because yeah, it's really interesting because we know our environment, the ecology, and so on, and how can we make any decision on that. So yeah, the question first about the how the satellite can detect or give some data about pollution, spectrum and so on. And yeah, the answer is satellite is just a tools, right? So the pollution, especially man-made pollution, and which then create a disaster. Of course, this is one thing that we can measure from the satellite. And then, for example, as I shown you before, the oil spill. Of course, we can easily identify where is the oil spill. And but the question is, if you get the person who spoil the ocean with who spill the oil in our ocean, then what you gonna do? This is a question always, right? So again, this question is always come back to the law enforcement. How can we really make the law enforcement is really useful to reduce all this kind of man-made disaster by pollution and so on. And then there are a lot of satellites already been launched, especially from Europe, from European, also to measure the environment, the pollutions with so many bands, also using technique like hyperspectral technology, so that every count of spectral lines can be detected. But then, to be honest with you, we have a lot of data already. For example, like we know how big is area already burned in Kalimantan, how big is the mines already has been planned or executed or whatever. But then the question is always, so what? When you have the data, so what? This is a question, right? So from us, from the technology point of view, everything can be measured anyway. Even we have a discussion last months ago, especially for the textile pollution, because for making the color, of course they will spread this the coloring directly to the river, and the river color will immediately change. And this can be measured, of course, from the satellite. And we have discussion with our colleague from research, nuclear research, that they can make the coloring back to the normal again by using a nuclear. And this is one of our research that we are going to have with them, especially for textile, because with some technique in nuclear, they can make the water come back again as a normal water. So yes, of course, again, this is back to the, okay, let's say in Indonesia, it depends on KLHK, right? KLHK will do that. From us, we are always supporting them. That's the reason why we have a lot of application like fire hotspot. We can also have the remote sensing data before and after evidence. Even when we say that Jakarta will sink, everybody just laughing, right? Because now and everything will be fine and so on. Of course, this is all politics. We will not enter that. We will not entertain that one. But as a researcher, of course, we will give all the data that what we have. And then the second question from Bu Isyara is, this is nice question, yeah. How precise the satellite can predict a disaster to happen? Of course, if you asking me, is it 100% Pak Yudi? Of course not. Just an easy task. Especially if you came from geophysics, you might understand that by measuring the Earth magnetic field locally or globally, you can use the signal as a precursor of earthquake. And my colleague from BMKG told me that they got an accuracy like 70% before earthquake happens. Anyway, this is still low, but should be okay. It is better than you don't have any prediction, right? Except you only, okay, berdoa is something else. Of course, you will need it. But as a scientific or researcher, you have to do something. And then, okay, they still get like 60-70% prediction for earthquake. So that's the reason why we have the data as well. We give them the data. And other thing like, for example, the landslide. By measuring, for example, because from the satellite itself, we can measure how big is our forest and how big is left right now. Of course, from that point, combining with digital elevation model, we can make some prediction. If some rainings comes, like a big heavy rain, the landslide may happen. But when it has happened, of course, we have to pray to God and hope not, right? So of course the accuracy is depend on the subject of the prediction. That's maybe my answer. Thank you.
Thank you very much. One more time for the participants. Bu Dewi can ask your questions to the Professor Indah Emilia. Okay. Oke, silakan Pak.
I want to question Prof. Indah. Can you explain about magic square in cryptography so that you get secret rahasia in the magic square? Thank you.
Thank you very much. But I cannot get the what is the mean? Can you explain once more? Magic square and the cryptography. I'm sorry, I cannot catch the question. So. I don't know. I'm sorry, I cannot answer this. Maksudnya, I mean, for the magic square, you add the secret, and then was it the cryptography? Was it the rule? Yeah. I don't know. Actually, I don't. I really don't know the answer. I'm sorry. No, I think cryptography is not in this part. I think the rule of cryptography is not in this part. Not make a secret in this rule, but cryptography is actually make how we can send message safely, such that another people cannot understand what is we send it. The message is be encrypted, and you can see the encrypted message, but you cannot understand the message like this. Yeah. So in this magic square, I don't know. I don't know how that we can use cryptography. Yeah. I'm sorry.
Okay, thank you very much. Unfortunately, we are in the end of the time of the sessions 1 presentations. If you want to have some questions, you can interact to both of the speakers via email if you wish. And I think it is enough for me to have the discussions for today's sessions. I'm as the moderator. Thank you very much for the participations. Wassalamualaikum warahmatullahi wabarakatuh.
The next agenda is a souvenir handover to both speakers by Vice Rector Professor Omi Sumbula. Time is yours.
The next agenda is photo session. Time is yours. The next agenda is lecturing session by Dr. Novadon Kitana from Chulalongkorn University of Thailand and Professor F.G.S. Wijen from Radboud University of Netherlands. That will be moderated by Mr. Navi Johari MSI. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabihi ajma'in. Bapak Ibu, I would like to welcome you again in this prestigious international conference on Greek technology held by the Faculty of Science and Technology, State Islamic University of Maulana Malik Ibrahim Marang. Thanks a lot for Bu Ari for guiding us for the first session. Very well, for the next talks, it will be delivered by other prominent presenters. The third talk will be delivered by Assistant Professor Dr. Nobadon Gitana, and the fourth one will be delivered by the professor by Professor Dr. F. Wichsen. Very well, Bapak Ibu, we will begin our session with 30-minute presentation for each presenter, and we will have the question and answer session after the end of the session. But before we begin the talk, the presentation, I would like to introduce our presenters. The first one is Assistant Professor Dr. Nobadon Kitana from Department of Biology, Faculty of Science, Chulalongkorn University, Thailand. His educational background is bachelor degree in zoology and also the master degree from zoology, 1998, and it's a master degree, another master degree in Boston University in 2002, and PhD degree at 2005 in Boston University, USA. His research interest is reproductive biology, comparative endocrinology, conservation biology, and ecotoxicology. Bapak Ibu, because we have very limited time, it's impossible for me to read all of the complete curriculum vitae, so I will read the brief one, the brief version of the curriculum vitae. There are a lot of publications has been made by Assistant Professor Dr. Nobadon Kitana, and our next presenter is Professor Dr. F. Wichsen. Family name Wichsen, first name Franz Joseph Servas. Sorry if I pronounce it wrong incorrectly, Professor. His academic education is bachelor degree in theology, first class honor, master degree in theology and pastoral studies in University for Theology and Pastoral Studies in 1984, and his PhD is in theology from Catholic University of Nijmegen. Sorry if I pronounced it incorrectly. At 1994, and his further studies is cultural anthropology and advanced Swahili, and there are many academic positions and publications of Professor Dr. F. Wichsen. Very well, Bapak Ibu, we will begin our session with the first presenter for the second session, and he is Assistant Professor Dr. Nobadon Kitana. The time is yours.
So good morning, everyone. Selamat pagi. So thank you very much for this opportunity. May I have my slide presentation on screen, please? Thank you. So first thing first, as the moderator mentioned about my curriculum vitae, that majority of my study is on biology. And then if you notice from the schedule, they mentioned about the animal physiology and conservation biology. These are my field of research. But of course, in this program with the green tech, sometimes my work is not yet applied to that field yet. So I need to move on something. But fortunately, right now, my current position is also related to something that I can share you with this international conference.
The slide, please.
Yeah, thank you. Sorry. So yes, my affiliation, right now there are two of them. The first one is Department of Biology, Chulalongkorn University, of course, and then the second one is a new name that called the Center of Learning Network for the region. I'll explain about that to you later on. Okay, thank you. The moderator just let me know that I can stand up and walk around. That would be better. Thank you. Sorry about that. So yes, it would be better for me to share some of my thoughts with you when I walk down here. So yes, originally I was invited to this one. I knew that it's about the green technology, and you know that biology in most sense is on the the basic science, not applied science. So when I got invited by the committee of the Green Tech, which is, I really appreciate that, I try to come up with something. So yes, next slide please. So my original idea about this part, if you follow or search through my name in the database, you see that most of the publication will be something related to animal biology. I have worked with the turtle, with the frog, with the crab. My most recent presentation is not anything related to the field of technology at all. But of course, with this basic science, it lead me or introduced me to the field. So next slide, please. During the time that I worked with the animal model like this one, can I have next slide? I have chance to share my knowledge in different fields. Next slide, please. One of the field that I share is actually international forum that is not scientific meeting at all. I joined, they call the regional forum. That would be for the office of the ministry or the people who have this kind of administrative power. So I shared this with them at the Philippines on the idea of this. And at that time, okay, my talk is about the animal that we can use to monitor the environment. But of course, the important thing that I learned from that specific task or specific forum that is about the word they call SDG or Sustainable Development Goal. I attend that in 2016, which is the first year that they implement or ratify that. So it's totally new for me. But of course, it's grown to many of the public attention. So can I have the next slide? So this, next one please, thank you. It become filtered down to the level of the university. If you imagine the Sustainable Development Goal, something that should be within just only the government, but of course they devise a good strategy. They come up with the tools to attract attention. Of course, in terms of business, they try to do good in the eye of the shareholder. So there are specific tasks for the business sector or for the SDG. But for the university, here I put the strategic plan of Chulalongkorn University, my university, to you. It have all of this colorful SDG goal in there because the university also want to play role in there. Why on earth we want to participate in here? You know that sometimes it's not easy to convince people in the academic sector to join you with something, except one thing. Can I have the next slide? The ranking. Yes. So the ranking game, the one that we want to share with, the SDG, even though it has been ratified by the United Nations, but they know how to attract attention, how to convince other people to join them in this task. So in case of the university, they use the Time Higher Education ranking. And of course, when we first get into that field, my university didn't pay much attention to that, but all of the work, all of the tasks that has been done in the past actually put us on a really top spot on the Time Higher Education. If you take a look at the academic ranking of Time Higher Education that just released this year, Chulalongkorn University is on like 500, 600, or sometimes 800. So it's not that far. But with the SDG, when they use the Sustainable Development Goal as a way to justify the ranking, we actually on top 100. And the most recent year, we got on the number 16 of the world, which is very far. We are very high. We are quite surprised on that. I knew that some of the university that below Chulalongkorn University is actually perform much better in terms of the research. For example, we are on 16th spot, but Hokkaido University, who has a really good environmental monitoring program, they have their own forest, they're on number 17 or something. So yes, ranking game right now, we knew is the best way to communicate, the best way to convince the people in the field of academia. So yes, university right now pay attention and they want to get better, of course. So can I have the next slide? For Chulalongkorn University, right now they have this unit, the one that I am currently working as the director, is called the Center of Learning Network for the region. And with this center, we actually bestow upon some tasks that relate to this sustainability. To the point that we have to set up the new vision mission statement that we will carry out the task on the sustainable living, sustainable life, and sustainable learn. So in this particular meeting, I will share you the SDG 15, which is one of the SDG that give us on the really top spot on the world ranking. Can I have the next slide? So yes, SDG 15, in the beginning, when we first entered into this field, we got on number 45, and then come up to number 23rd, and right now we are on number 16 of the world. SDG 15, they talk about life on land. So basically they talk about the conservation. If you take a look at the target and indicator of this SDG, it is something that probably we feel, yeah, we cannot do that because they're talking about to reduce the amount of forest degradation, to prevent desertification, you need to increase the amount of green land. Sometimes, yeah, we are far away. It is far-fetched from the academic thing. It is far-fetched from the publication that we do. But of course, the time higher education, they have a way to communicate with you. You don't need to go through or work as a government, but you can contribute something to that. And this is something that I would like to share to you. Can I have the next slide? So a brief information that I would like to share to you, because SDG 15 covers so many things, but what I would share to you is on the case of deforestation and forest degradation. This is a picture of Thailand. Yeah, in the northern part of Thailand, Nan province. I'm not ashamed to show this to you because all the mountain, the forest over there, it is protected area, believe it or not. It's a protected forest, reserve forest. But sometimes the protected area, the decoration of that protected area is actually after the settlement of the human. So human settlement has been there already. There's a hill tribe people, local villager who stay there. But all of a sudden we announce the area for the protected area or the protected forest. So they're not going to go anywhere because it's their home, and they still use that for plantation. The thing that we worry most is the single crop or monocrop plantation. They grow corn a lot because in that land, the water, the irrigation system is not that good. So the only crop that they can grow is maize or corn. And maize or corn, they use it for, not for human consumption, they use it for animal feed. So you know that it's not turned back to us anymore. I mean, they will be go into the contract farming. So encroachment of the land is really bad. So what we going to do with that? Of course, there's a lot of persuasion, a lot of things that we need to do. So first thing first, we need to find a way to reforest. Of course, everyone know that. You got deforestation, you need reforestation. But it's not easy. So let's have the next slide. What we did is actually based on the research in the field of basic science. This is the work of my colleague, Dr. Chitra Piapukiao in the Department of Botany. She studied the relationship between the plant and the fungi or fungus. And we knew that underneath the soil, when we see that the top of the soil, there's a single plant, but underneath there's an ecosystem, a really complicated ecosystem that called mycorrhizal. Mycorrhizal because it's about the fungi or fungus, and rhizal because it is the root of the plant. And underneath that, a big community, a really complicated relationship that occur over there. If you move all of these components, of course, the plant cannot grow. And that's one of the reasons why the reforestation is not so successful, because you just give the plant in the land that is so desert, there's nothing for them. You need to bring them some companion. So ectomycorrhizal fungi is the companion that we're going to talk about. So next slide, please. So here, Dr. Chitra, to make the long story short, Dr. Chitra actually identified the symbiont mycorrhizal fungi in there, and she knew that there are plenty of them. Of course, roughly speaking, you can say that the plant require mycorrhizal fungi, but 80% of them use endomycorrhizal fungi, meaning that this is a fungi that infect and stay within the root cell. But in this case, the forest that we're talking about is deciduous dipterocarp forest. They require the ectomycorrhizal fungi. So they are just 20% of the plant that require this ectomycorrhizal fungi. With this ectomycorrhizal fungi, of course, you can inoculate, you can find so many of them. But what would be the best strategy? You can choose any one of them, but in case of Dr. Chitra, she actually chose this one particular type of fungi that can produce the mushroom. This is the mushroom, which is very expensive, to be honest. This mushroom can be sold for 1 kilogram. It can range, it depends on the season because it's wild mushroom. But we convert to IDR, it will be 200,000 IDR to 300,000 IDR per kilogram. Really high price. And right now, we have another way to persuade people to join in this task force, because we inoculate with this in the plant setting. Of course, they enhance the growth and survival of the plant, but in addition to that, it becomes the edible mushroom. Before that, when we go to the villager, to the hill tribe, and ask them to grow tree, they ignore that. Yeah, why? They don't need to do that because there is no penalty on them. Of course, we need to have some positive reinforcement. So in this case, we let them know that if you grow this plant, in the next few years, you get mushroom, you can harvest, you stay together with the forest. So it becomes a good strategy for us. So can have the next slide. So yes, right now, at my Center of Learning Network, so the region, we're responsible for this. We make roughly about 150,000 of this seedling every year. We distribute to other area of Thailand, mainly focus on the northern part and the central part of Thailand. Every seedling, we have this inoculum of the mushroom. It's not that difficult. For you as microbiologists, so sometimes you feel that inoculum, you must use a really fancy technique, but no. We actually have the stock of the fungi, and then once we're done with that, we make that into a broth, and we just water the seedling with this broth, and they'll find a way to get into that plant. Once we have that, of course, there's a demonstration farm that we see these different kind of mushroom that grow into that. So yeah, we need this strategy. But the interesting thing that we find afterward, can I have the next slide please, is that it's not just the mushroom that we put there. We put this specific type of mushroom, but for some reason they grow and then they bring other mushroom into the forest as well. So it's not just only the mushroom that I mentioned to you. There are plenty of other wild mushroom. All of these are edible mushroom, and they sell for a price. You cannot buy in supermarket. You cannot buy in the convenience store. Of course, you need to find a local village or local market that can harvest this mushroom. So it become more and more popular right now for the point that we for the technique that we use. So can I have the next slide? So let me sum up some of the, I would say that 3 techniques that I would like to share to you. The first one, based on the study of botanists as well as microbiologists, is using these ectomycorrhizal fungi. We put the fungi in this seedling, inoculum them with the simple technique, and then we end up having these, they grow together. This is a mushroom, this is a fungi that in there. And if you are a biologist, you know that the mushroom is actually the reproduction stage of the fungi. So yeah, actually in this plant potting soil and in this plant potting bag, you're not going to see the mushroom yet. You see just only this kind of the fungi in here. So this is the first technique that we use, and it's based solely on the biology that we study. Next slide, please. But of course, the challenge that we got when we really put that into test in the real forest, let me tell you first that originally what we do is we make a small demonstration plot, but then when we want to expand that to make sure that the public sector also have some example. We find another challenging that in northern part of Thailand, water is not so plenty. So we need to find some way to do that. So we actually, based on the information that we got from the study from chemical technology department, we bring in this biopolymer. So you know the biopolymer, they can absorb water. So we can increase the amount of humic substance, we can increase the amount of moisture in the soil. And once it's there, it will be degrade within 2 or 3 years. So it's good for the seedling so that they can setting themselves in the soil. Usually what we did is that the first 1 or 2 years, we knew that they can stay there and they provide the water for the plant. But once the plant can set up by themselves, they just degrade and leave no residue to the soil. So this is the second technique that we use. And can I have the next slide? But those two techniques, the ectomycorrhizal fungi and the biopolymer, is good if you want to do reforestation, meaning that you get into an area that was the forest before, but it was clear-cut or it was something. But when it comes to afforestation, you talk about bare land. There is no tree, no grass at all. Sometimes it's challenging to put the tree over there. Basically, they will die out. All of them is die out. So what we did is we used the technique that devised by this Professor Akira Miyawaki from the Yokohama University in Japan. He make this, sometimes they call eco-forest, sometimes they call Toyota forest, because Toyota is the one who kind of brought about this idea throughout the world. But Miyawaki technique, if you search through the internet, you see a lot of them. It's good for a small plantation. Instead of plant it in the bare land and let them sit there and wait for them to die, we actually create the mound for them. With this mound, we put a large number of them. You know that usually when you go into any plantation, they will say that you need to have some space between the plant, you need to have 4 by 4 meter. But here, within a single square meter, we put more than 4 plants in there. So we put a really high density. But with this high density, they actually create one phenomenon that we call competition. So yes, in biology, competition is one strategy that they need to withstand. With high amount of tree in here, they compete with each other so they can increase the growth dramatically. If you plant them far from each other, sometimes they just stay there and they die. But for some reason, when they compete each other, they get stronger, grow faster. We have the example that we put that into demonstration plot, and we see that within just only a couple of years, they can stay there and any one of the tree die. So can I have the next slide, please? So yes, this is the one that I mentioned to you. It's bare land. It's within the center in Nan province, and we grow here for just only 4 years. And you know that 4 years for Dipterocarp forest, it is very challenging because they can grow really, really slow. It's not like eucalyptus. It is something that grow really slow. If you put that into the forest, sometime within 4 years, you can get just 1 meter tall of the tree. But here with this Miyawaki plantation, we get more than 2 meters, or sometimes even some of them go to 3 or 4 meters. So can I have the next slide, please? So of course, in this demonstration plot, we also see the evidence of this mushroom. This is mushroom, mushroom, mushroom everywhere. So it's proof of evidence, it's a proof of evidence, it's a proof of concept that we have this land. Any of the villagers who have the curiosity, any of the government sector who want to learn something can come to this plot and see the real thing. We didn't put anything special. We just put the seedling that we have inoculate with this ectomycorrhizal fungi. We put biopolymer in there, and then we use Miyawaki technique, and that's it. So we have this. So right now we expand that to, I would say that roughly almost 2,000 hectares of this already not 2,000. Yeah, approximately, I would say 200 hectare, sorry, for the demonstration plot. We say demonstration, but it's really large land because we go through different parts. The 200 hectare that I mentioned are actually just based on what we learned. Then, of course, we knew that we have the seedling for more than 150 in each year. So we distribute to other organizations so that they can grow as well. Can I have the next slide, please? Oh, sorry. Probably this is a video that shows the mushroom in here. You can go to the next one. So yes, right now I need you to help me with clicking because there are animation on this. So to sum up what we did with this, of course we use a different technique and different plot depend on the location, depend on the type of land that we face. So yes, first thing first, the first click please. We have, can you click on the slide? Yeah. Underneath we have this biopolymer in there, of course, to help increase the amount of the substance or the humic substance in there. Next one. And then we add mycorrhizal fungi, and this fungi will eventually become the mushroom for you to eat later on. Of course, there are other components as well. Can you click about 4 or 5 times? Yep. Yeah. Next one. Yep. A couple more. Yeah. At the very end. Yep. Thank you. So we actually put other components in some specific area. The one that I mentioned to you, we use it for the real forest. I mean, for the reforestation and afforestation. But for some afforestation, we have a problem with the weed. So we use the sun hemp. Sun hemp not only just produce some nutrient in there, they actually shade the growth so that we don't have to worry about the weed. And then there's study by the student, some of them is Indonesian student who study in Thailand, and see that the increased this of the enhanced plot that we have, we can increase the amount of the under the soil fauna, and then some of the insect there. Some of the insect is not a good insect. Sometimes they come here to eat the plant, but of course they can attract the bird, and we knew that in enhanced plot we have the bird that can come here. So eventually we create a small ecosystem in there. And eventually what we did is that we follow up the growth, we calculate the biomass, we calculate the amount of carbon, and we learned that within 4 years, each plant actually accumulates 780 grams of carbon dioxide. If you let it grow for 15 years, they can accumulate 8.7 kilograms of the carbon dioxide. And you know that with the COP21 that we mentioned, a lot of nations, especially Thailand, we declare that in 2050, Thailand will become carbon neutral country. It means that we have all kind of activity. We produce, we emit a lot of carbon dioxide, but we will try to capture, offset all that. And one of the tools that we're going to use, of course, plant tree. This is the one that simple thing that we can do. In addition to this, so right now, the university also pay particular attention on how to offset the carbon to the point that we can offset, we can balance that. In Thailand, the announcement by the Prime Minister say that we will be the carbon neutral country within 2050. But for Chulalongkorn University, we challenge ourselves. We will be the university that become carbon neutral in 2040. So meaning that 18 years from now, any activity of the university that emit the carbon dioxide will need to be offset or absorbed. And plant tree alone is not enough. We need to have other kind of technology. But of course, the plant tree is a simple thing that we can go. So next slide, please. I just want to say to you that plant tree is not just only a fancy word anymore. There's a science underneath that. I mean, we have the supporting evidence for that. And of course, we can increase engagement. This is a project that we perform with the Yves Rocher Foundation. That project that could call Plant Tree with Yves Rocher. So Yves Rocher actually provides support, I mean money, for the university so that we grow plant using this technique as well. And of course, next slide please. In case of the community engagement, this is the one that you can do. You have bare land, you have villager, you can bring students there, you can bring the staff there. So we have the project with the foundation that called Rak Pa Nan, which is conserve the Nan in the Nan forest in northern part of Thailand. And this specific project is actually initiated by Her Royal Highness Princess Mahachakri Sirinthorn of Thailand. So we have a good endorsement for this project. So next one please. So all the thing that I share with you, of course, if you have if you need further information, you can take a look. I mean, there's an abstract that kind of outside of the abstract book because I sent it late. And there's a contributor, Chitra Piapukiao, and her PhD student who work pretty much everything on the ectomycorrhizal fungi. Dr. Vichet Konsu, who is former director, who initiate the program, put the biopolymer there, use Miyawaki technique. And then there's Dr. Pongchai Damrongrod Watana, who is also the one who work on the carbon sequestration and carbon stock of this plantation. And Dr. Nipada Ruenkao Disyatat, who study about the balance of ecosystem underneath the root as well as other mycorrhizal fungi in there. And of course, my team at the Center of Learning Network for the region, I cannot put their name because there are hundreds of them who help me in terms of planting the tree to different parts of Thailand, in Saraburi province, in Nan province, and also in some of the northern part who have facing with this forest fire. So thank you very much for your attention. I will entertain your question later on during the discussion part. Thank you.
Very well, Dr. Nopadon Gitana. Thank you very much for the informative and interesting talk. Even for me, for non-biologists, I'm really interested with your talk. If you have any question, Bapak Ibu, save it for later, because there will be our second presenter will be delivered by Professor F.G.S. Whitson about intercultural and interreligious. The time is yours.
Thank you very much. I'm going to take a little bit a different position. I position myself here, a bit higher than the others, because I'm going to talk a bit from a different perspective, a quite different perspective, not about mushrooms or digits or satellites, but maybe about God and spirits. Well, anyway, thank you for the invitation to speak to you at this very important and interesting seminar on empowering innovative science and technology for future environmental perspective. I'm going to do so from a non-science and technology perspective, from a theological perspective. Maybe you can share my PowerPoint. And I thank the Dean, Dr. Henny Widayani, for the invitation. My topic will be green theology and green technology. And I'm a bit surprised because in theology, my background, there is a lot of talk about green or clean theology, eco-Islam, eco-Pesantran, eco-Dharma, and so on. I can continue for half an hour. But there is no connection between green theology. And I think it is important to make that connection from a humanities perspective. Because I think that we really can make a contribution and help each other. I link to the discussion in the first discussion round. Ms. Zaimatus asked the question whether satellites can measure human-made pollution, and Dr. Yudi answered, yes, of course we can measure, but so what? What is the problem? And I think that is very important where humanities comes in. Of course, people see pollution, people see plastic waste, but for many people it is not a problem. They don't interpret it as a problem. And I think with all the environmental issues, of course we can measure, we can do many scientific studies. But ordinary people, they interpret it from their cognitive frame. And they don't see the problem. They take it for granted. That's normal. And I think that's where a humanities perspective comes in. So I'm going to talk about theology and technology, humanities perspective on innovative science. Innovative science. What for? What is your vision? Where are we going to? Here again, I think that is something that from a humanities perspective we can add. Next slide, please. What we have seen over the past decades, from a technological point of view, we can make green products. We make them in the laboratories of our universities or in a company, but they are not used by ordinary people. We have seen water purifiers, very good technique, not used. We have seen toilets, very good technique, not used, because they are not designed from a user's perspective. And that is where I think a humanities point of view can come in. How do people think about our technologies? What is the problem for them? Moreover, so I think that's for a technology perspective. A humanities perspective can say, okay, but knowledge, what for? What is our vision? Where are we going to, or where do we want to go to? And I think for business people, it is interesting to see the business opportunities in the market to create green and clean products that are accepted by people. I'm going to give a little example about plastic. I will do that later. First of all, I will talk about a theory. I don't have many nice pictures, or I have no pictures at all. But I just give you the outline of my talk. First, I give you the theory. Second, I talk a little bit about what is the issue that we talk about, the approach of our study, findings, a correlation between the theory and our findings, and a short conclusion, and that all in 20 minutes or 25 minutes. So first of all, the theory. Next slide, please. So when we talk about environmental degradation, for many people the question is, what is the problem? They accept it as normal, as a fact of life. So when we define something as a problem, I don't want plastic, I need a normative reference. Why? Why do we have to abandon plastic? Of course, we can look at it from a scientific point of view. But when we think, well, this is not good for Earth, or this is not good for our health, we need a normative reference, and that is where humanities comes in. Now, what I see in Indonesia, and that is quite interesting, that you speak about innovative science. 2 weeks ago, I spoke in the same university about integrated science. We have seen a shift from Islamic institutes focusing only on religion, the EINs, to the UINs. Where science and technology integrate with Islamic studies. But how to do that? That is not so easy. Some people speak about an Islamic science or a sacred science, but what is it? Science is science. Personally, I don't see what an Islamic science or a sacred science is. Science is an autonomous reality. But, of course, from a humanities perspective or a theological perspective, you can ask science for what? What is the normative frame? Where are we going to? That is where religious and theologies are good at. They have a vision. Where do we go to? That is something that a scientist cannot do. You simply explain. You explain causal relationships. And maybe you come up with a solution. But solution, what for? And I think also the theological perspective can go into the epistemological foundations. And what are our axiomata of science? Our starting points that we cannot prove. Basically, science and technology is also belief. And that is something that science and technology share with theology. Well, so we need to go from a compartmentalized approach, where theology and technology operate separately, to a more integrated science, and I will do that from a dialogical self perspective. All of us, you, I, take a multiplicity of positions. We are sometimes believers, we are consumers, we are parents, we are also scientists. These are autonomous positions. Sometimes they compete, sometimes they collaborate, sometimes they make consensus or a coalition, and that is how I look at the linking technology, science and technology, and theology. So what I'm going to do, I'm going to talk about a project that my doctoral students and I do on plastic waste. Next slide, please. What is the issue? Well, I'm not going to bother you with a lot of data, because you know that Indonesia has a population growth of 1.5% per year, an urbanization growth of 4.1%, and an economic growth of 6.1%. 60% of Indonesia's people now live in cities, producing enormous waste. 200,000 tons of waste per day. 70% of that waste is plastic. We produce in our cities over the past decade an increase from 0.8 kilogram per person per day to 2.1 kilogram waste per day per person. Enormous quantities. And of course some of those waste items, they really cause problems. Now, 70% of Indonesia's plastic waste is burned. Now, when you burn plastic, toxic gases release, which is a direct cause of climate change. So there is a direct relationship between plastic waste, the way we recycle or not recycle, and climate change. Now, the Indonesian government promised to the international world to reduce plastic waste by 70% in the year 2025. That is not very realistic, but okay, it is a commitment. And the Indonesian government asked faith-based organizations and all civil society groups to help the government reach that goal. And some of the large Islamic organizations in Indonesia, Nahdlatul Ulama, Muhammadiyah, promised to do that. They came up with all kinds of regulations to reduce, to discourage the use of plastic. Now I will go a little bit deeper in the reasoning, but the mainline reason is that plastic is not forbidden, it is not haram, but it is discouraged, it is makruh. Now, and of course, as a theologian, I'm interested, okay, but why? Why is it not haram? Why is it makruh? And we try to find out the reasoning talking to religious leaders. But the fact is, and that is where our interest comes in, that many Islamic organizations in Indonesia produce plastic waste. As you know, there are many organizations, Islamic organizations in Indonesia, also the pesantren, that have mineral water as an income-generating project. It is very profitable. 280 million people drink water. Now, you can make a lot of money by selling mineral water, but you distribute it in plastic bottles. And that is something strange for me, because on the one hand, Islamic organizations say, we don't want plastic, we discourage plastic. On the other hand, Islamic organizations produce a lot of plastic. So that is the issue that we are interested in. And so we have a lot of questions. Why do religious leaders say, well, this is not haram, but it is makruh? What is the reasoning behind it? Now, let's say if plastic is discouraged, and we know that there are many biodegradable bottles, alternatives for plastic. By the way, it is interesting, you know, when you deal with plastic, it's very simple, but it becomes an obsession for you. Always when I see plastic, I look at the bottle. They say, this is eco-friendly, 100% recyclable. Come on. Yeah, you can recycle the bottle, but microplastics will always be there. They cannot be recycled. I mean, every day that we produce more plastic, more microplastics in our water, in our vegetables, fish, and so on and so on. So this is fraud. I mean, what they write here is simply, in my view, not true. Good. So what we did, next slide, please. So what we did, of course, it is a qualitative research. We did a comparative research in 2 Islamic boarding schools in Pasuruan, not far from here. One is considered a modern pesantren, the other one is considered a traditional pesantren. Both have their own brands of mineral water. One is called Al Yassini, pesantren, Pondok pesantren Al Yassini. The other one is Sidogiri, that produces the Santri mineral water. And we expected, talking about green technology, that the modern pesantren would be open for modern technology, green technologies, and the traditional pesantren, we expected that one would be reluctant to change. And basically, well, what we tried to discover with the KI, with also the chief executive officers of the cooperative unit that produce the plastic bottles. So why, just explain why is plastic not forbidden but discouraged? And if there are biodegradable bottles available, and they are available on the market, so real biodegradable, not what these people say on the bottle, why don't you go for the alternative? So these were the very simple questions that we had in mind. Next slide, please. Now, of course, I have to summarize. I have only 25 minutes. But some of the arguments that we found in both pesantren was that, well, one of the reasons that people gave is that there is no scientific evidence that microplastics is harmful or risky for our health of natural environment, which is true. So far, there is no hard evidence. There's no hard evidence that microplastics are dangerous for our health. But they are expected, and there is enough evidence that there are many health issues involved here. But they say for making something haram, we need really scientific evidence. And there is always the relation, the comparison with smoking. Smoking, well, there is evidence, scientific evidence that smoking causes cancer, but unfortunately some people die, other people don't die. So that makes it a bit complicated in Islamic lawmaking. Another argument that is used by the religious leaders is that plastic is not forbidden by the government. Now, if it were forbidden by the government, the religious leaders would make a rule that people have to follow the legislation or the law by the government, fardu. And they say, well, you know, we religious leaders have only moral authority. We don't have a legal authority. Then, of course, the question is, okay, that may be true, but why don't you take the lead as religious leaders? You have a vision that you don't want plastic. And, well, they say, well, we simply don't have that authority. Although the government of Bali, as we know, already banned single-use plastic. And one of the companies that produces plastic, they already shifted from the category 1, so the problematic plastic, to category 5. So that is already an achievement. But of course the next step would be, we don't want plastic. Not reduce, recycle, reduce, but refuse, reject, zero plastic. Yeah, another, I'm not a scholar in Islamic jurisprudence. People here are much better in that. But one of the other arguments is that the risks are not immediately visible. Here again, there is a comparison with smoking. We know there is scientific evidence that smoking is bad, but the effects are not immediately visible. And maybe the effect is only visible after 20 years. And, well, the experts in Islamic jurisprudence say, well, also then it is very difficult to make something haram. So these are some of the arguments that we found for not forbidding plastic. Now, the other question is simple. If there are good alternatives for plastic, and there are on the market, why don't they go for the biodegradable ones? Well, a very simple reason, an economic reason. The biodegradable bottles are more expensive. Now, that could be a reason. But the price of a product depends on the market share. If more and more people go for the alternative, the price goes down. It is very simple. And what I did not tell you, we found in Pasuruan, some of the pesantren, or let me say one of the pesantren, produces more than 500,000 bottles per day. Per day. Only in Pasuruan, we speak about millions of bottles produced by Islamic organizations. And not only the bottles, but also the cups. You know, the small cups and the larger cups, millions. So it is a huge problem. And of course, when you have a huge market share, the price goes down. And then we come to a theological level of the debate. Biodegradable bottles are not transparent. Here again, we enter into Islamic jurisprudence. But in Islamic jurisprudence, for ablution water, water must be transparent. It must be clear. It may not smell. It may not have color. And the Kiai say, well, you know, that's not a problem. So our question is, okay, when you go to Indamar or whatever, you buy susu or you buy a juice in a carton bottle, no problem. But why is it a problem for water? And then they say, well, there is not a theological problem because the rule that water must be clear only applies to ablution water. So in principle, it is not a problem. But in the mindset of the people, could be that applies to all water. And that is why people prefer, they want to see clear water. By the way, another problem is that people think this is clean, this is pure, as they say on the bottle. But of course, it is not. Because if I measure this water, I know there is microplastics, possible there are chemicals, possible there are antibiotics in the water. We know that. So it is not clean, not so clean as the producers claim. Yeah, and then a last comment that they made is that the plastic bottles are a source of income for the people who collect them. Yeah, that may be true, but I don't see that is a strong argument against going for alternative bottle. We have to find other sources of income for those people who earn their living by plastic waste. So, next slide, please. When I try to correlate, theology, eco-theology and eco-technology, I think for you people, technicians, scientists, please help us to make bottles that meet the criteria of the Islamic jurisprudence, or that meet the criteria of people who are going to buy this bottle. It is a bit more complicated because on some of the bottles that we saw, I think it was the Al Yassini water, it is written, it is Sehat dan Berkah, it is healthy and there is a blessing. Well, it is not so healthy as it is claimed. But why doesn't the EPI say, well, this is not very blessed, I give my blessing to the bottle that is 100% biodegradable. So, the question, but we don't have that bottle. Or maybe it is too expensive. So help us to produce bottles that are 100% biodegradable, that meet the mindset of the people, and are marketable. That can be produced at a low price. On the other hand, scientists can help theologians and Islamic jurisprudence to make clear that, well, you say that this is healthy, but it is not. I mean, from a scientific point of view, we know that there are all kinds of microplastics, chemicals, antibiotics, and so on in this water. So in this sense, I think that really science and technology and theology can strengthen each other to overcome this big, in my perspective, issue of plastic waste and reduction of plastic waste. Next slide, please, and then I come to my conclusion. Well, how can we do that? Well, the way forward is what we call a living lab approach. I said at the beginning, we have very nice green products, but very often they are not used by the consumers because they are not taken into account. Next slide, please. So by a living lab approach, we mean that you don't have a laboratory in the university or in the company, but you bring the engineers to the people, together with the people, with activists, with religious leaders, with the local entrepreneurs. You can say, okay, what is your problem here? How can we solve this problem here? Not in the university, but on the spot. And that would be really a great way forward. And we have many examples in Indonesia where people use this approach. Last but not least, I spoke in the beginning about the compartmentalization. I have many nice examples where water engineers, economists, policymakers do a great job, but there's no integration at all. No integration at all. Everybody does his or her own thing. And we are very good in things, but there is no coordination. So what I think is needed, or a way forward, is not so much a disciplinary or multidisciplinary or interdisciplinary approach. And we can think about an integrated science, trying to link different disciplines. But what is also needed is that we dare to think beyond our disciplines. Where are the gaps of our knowledge? Where are the open spaces in our knowledge? That is not to do away with the disciplines. Disciplines do a good job. But in overcoming some of our environmental issues, going to environmental, new environmental perspective, I also think that we need a new approach, and many scholars call that a transdisciplinary approach. I think Dr. Wahyudi, you come from Boga University. I think in September you had a beautiful conference about transdisciplinarity. I was very inspired by that. So it's not a complete new idea. It is being used in Indonesia, and I would challenge you as the conference on green technology to also look in this new approach of transdisciplinarity. I thank you for your attention, and I look forward to the questions.
Thank you, Professor. Very well, Bapak Ibu, let's give a big round of applause to all of presenters for the interesting and informative talk. And we are now come to the question and answer session. If you have any question, please raise your hand, mention your name, and state to which presenter you address your question. The first question will be from the behind. Could you please hand over the microphone, please? Please mention your name and state to which presenter you address your question.
Tes. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Let me introduce myself. My name is Nadila Zakarzaida. I am from Department Biology, Faculty of Mathematics and Natural Sciences, Malang State University. I have question to Mr. Nopadon Kitana. I have two questions. This first question is, why do you use Astreus odorantus and Astreus asiaticus as a short edible mushroom for reforestification? What's your reason? And second question is, Termitomyces is another genre of edible mushroom that live in termite comb. Does Termitomyces also can use for reforestation? Thank you.
Thank you very much. I'm sorry, Dr. Nobadan, I cannot repeat the question for the biological term. It's a very complicated
That's
for me.
all right. I get that question. Thank you very much for your question. Very interesting one. Actually, the two questions. The first thing is why we use those two mushroom. I'm not going to recite the scientific name, but those are the mushroom that we use. First thing, when we go into the field, there are plenty of mushroom that you can select from. But you know that mushroom, some of them is not edible, is toxic. This one is edible, and they fit the category. What we aim for is that to find mushroom that can enhance the growth. So we try with various kind of mushroom. And what we see, this is something of the secret, is that only this kind of mushroom that we can grow in the petri dish. Other mushroom, you cannot get the hyphae or hypha of the mushroom at all. So basically you need to use a fresh mushroom and inoculate them. But in case of these two species, you can grow into the petri dish. They grow the hyphae. You can make a stock and make it a large stock of this. So that's the reason. And the second reason for that, of course, is the price. Of course, fortunately for us, this one, it can grow in the laboratory. But of course, if you have various kind of mushroom to choose for, the price is one thing, because you want to persuade the villager to help you in terms of reforestation. And your second question is the one that grow with the termite. Unfortunately, is not part of ectomycorrhizal fungi. It means that they cannot symbiont with the plant. They cannot form symbiosis with the plant, especially the one that I mentioned, the Dipterocarp forest. For some reason, they don't like each other that much. They have some plant that can grow nearby the mound of the termite, and they can enhance the growth of that. But for some reason, the Dipterocarp forest that we use, all of the one that we have as a native species, they don't like that much with that mushroom. So that's why we can. But of course, it's a good way to go to, because that one is also very expensive. Thank you.
Thank you very much. From Ibu Nabila, does it answer your question?
Thank you very much for answer. Yeah.
Okay, thank you. The next question. If you have any question, please raise your hand. Okay.
Bismillah. Introduce. My name is Mujahidin Ahmad. I am a lecturer in Biology Department, Faculty of Science and Technology, State Islamic University of Maulana Malik Ibrahim Malang. My question I will address to Dr. Nobadon and also Professor Wilson. The first question is, what make the mushroom so expensive? Is there any some of advantages that can we get from this mushroom? Maybe can be used for medicine or any purposes. And then the question for Professor Wilson is, we know that we realize the plastic is become our problem, especially in Indonesia. Indonesia become the second largest population of plastic, and any institution have some of policy to how to solve this problem. So regarding with how the maybe some of countries based on your experience, maybe we realize that European country have advanced technology and maybe a policy and some of things that can implement in our country, especially in Indonesia. So my question is, what your advice, especially for the scientists, practically or theoretically or theologically, how to solve this problem? Okay, thank you very much.
Pak Didin, the first question is for Dr. Nopadan, and it's about what does make that mushroom is very expensive.
Thank you for the question. Basically, it's just about the demand and supply. Basically, is because this mushroom is wild mushroom, you cannot grow into any of the culture in the laboratory setting or in farm setting. So you need to harvest from the wild. And you can have it as much as only 3 months per year. So just only 3 months that you can have and you can eat this. So there's a way to preserve it in the can, put in the salt water or something. But usually people prefer to have the fresh mushroom. And I think that's just only the supply side. And of course in this area, because of the water that we have is not that much. So they say that the mushroom come from this area is very tasty. So they have a really good demand for a short supply. That's why they make it expensive. But of course we know that scientific evidence also shows some of the prebiotics in there. But I think at this point they don't worry much about the prebiotics in there. They just want to get this because of the taste and because of the short supply. Yeah, thank you.
Thank you very much.
Well, thank you for your question. Indeed, Indonesia is the second largest producer of plastic waste after China. And to make it even worse, you even import plastic from my country on top of that. Yeah? So that makes it very complicated and a global issue. And I feel ashamed for that we, my country, transport plastic to Indonesia to be recycled here, because in Europe it has become very complicated. I think the answer to your question is quite simple. It is not a technological issue. You have the technology. You don't need to go to Europe. You are able to make alternative bottles based on wood fiber, cassava leaf, banana leaf. There are many examples on the Indonesian market already. But I think there are two issues here. The first, I come back to my point. Many people don't see the problem. That is here again the humanities perspective. So what's the problem? You see, I see plastic waste everywhere, but that's not my problem. The government has to solve it or whatever. And I think also in the first session it was mentioned lawmaking in the European Union 2020-40, plastic free, simple like that. But lawmaking starts with you, with us, with civil society groups who say we don't want this anymore. And so when there is enough support for alternative bottles, that will translate into law. And of course then we hope that the laws are implemented. And of course that is not always easy, but for me it is not primarily a technological problem, in the sense there are good alternatives. They are not always marketable, but I think it starts with you and me, consumers, saying we don't want that bottle, we want other bottle. But when I go to Indomaret or whatever market, I don't have any option. I can choose 10 brands of mineral water. It's plastic, 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 plastic. There is not one alternative on the market. So somebody must start.
Thank you very much. Is there any other question, Bapak Ibu? Okay, please.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. I would like to ask question to Professor Franz. Thank you very much for a very, very powerful presentation and very important for Indonesia. That has been my concern in the last 5 years. And I hope that you, for me, one powerful approach to alleviate this problem is to integrate this one into the school curriculum. So we have a new curriculum called Curriculum Merdeka, and I am working on a project called STEM practices, and actually what we are trying to do is to develop these STEM skills for early learners and elementary schools, and we have to be very explicit about problems in Indonesia and to stimulate their curiosity and also to recognize the real problem in Indonesia.
I know in Australia there are so many problems in terms of waste, all right? Lots of objects or lots of stuff that are thrown away, while in Indonesia they will reuse it for many years. But in Australia there are so many problems in terms of that. But if I have to say one major problem in the society in Indonesia is the use of plastic. Plastic is everywhere, all right? And it seems our society didn't actually realize that, and the learners at school see that as a very normal practice, very normal practice. So I am happy to, let's say, if you need to have a connection with the policymakers in the Ministry of Education, for example, in particular, how to make them realize that this is a real problem. Yeah, thank you so much. So that's just a comment. Thank you.
I fully support.
Very well, Professor. Do you have comment for that statement, or perhaps want to add some points to the comment or statement?
Well, just to link up with the last contribution, I mean, the Ministry of Environment has implemented environmental education, I think in 2008 already. There is a program on eco-pesantren, but that's where again the humanities perspective comes in. I really don't understand. You have an eco-pesantren or a pesantren. You say, well, you want a clean environment, but at the same time, you produce plastic bottle. I mean, I can understand. You can make a lot of money, because we all need drinking water. And I can understand that Pesantren needs the money to sustain itself, because it doesn't want government support. That part of the story I do understand. What I don't understand is that, okay, but I can also make money. And I think for entrepreneurs, for the next decades, there are really market opportunities to go in the other direction. And yeah, in my perspective, the religious organizations should take the lead in that, but they don't for one or another reason. Well, I showed that there are many complexities in reasoning.
Thank you very much. And Bapak Ibu, I'm afraid that the last question is the last question for this session. So if you still have any question to Professor Witsen or to Dr. Nobadon, you can contact them personally. Very well, Bapak Ibu, let's once again give a big round of applause to all of our presenter for the interesting and informative talk. And thank you very much for active participation. Assalamualaikum warahmatullahi wabarakatuh.
Okay. The next agenda is souvenir handover to speaker by Dean of Science and Technology Faculty, Dr. Sri Harini, MSE. Time is yours.
thank you to all speakers. After this, there will be a break from when we close this by the MC until 13 p.m. And after the break, there will be another agenda, which is a parallel session, and for the room allocation for all attendants will be announced later by the committee of the event.
نحن كسيد الحكيبة الاحتفال نعتذر إذا كانت هناك أخطاء والله الموافق إلى أقوم الطريق والسلام عليكم ورحمة الله وبركاته.
Oh.